Hi, my name is Matt Stern.
And I'm Albert Liao.
And our project is called DJ Party. It's a project that will allow you to collaboratively make music, not in real time, and will also allow you to learn songs by ear with a great teaching algorithm that we've written. So how the project works is there's an 8-button keyboard. Each note can be customized via a command line interface, which is used to interact with the board. So for instance, if I wanted a C scale, which is the default, it'll do that. I could add sharps and flats or do a completely new scale, or just not even a scale, any customization of notes. You'll see here that there are actually 2 prototypes. They're not connected in any way. So for our demo, we're going to show how we collaborate to make music. I'm going to make a song on my own board. And I'm going to be able to send it to Albert's board via our IR transceiver, and then he can add to it and superimpose his track onto mine, and then he could send it back to me where I could continue superimposing, and we can create a song that's not in real time.
Okay, and the IR transceiver is here, and the other one's here, and the internal representation of the music is all MIDI.
Right.
Right, so you record from MIDI with the keyboard and you play back MIDI with the synthesizer.
Right, that's correct. So what we do is when we try to play back a MIDI file, we have a pointer that goes to the file, and whenever we see that a note should be on, we play the corresponding sound that we described.
Okay, let's hear it.
Okay, so first what I'm going to do is type a command record into my command line. This will begin recording, and I can exit any command with this button here. So I'm going to go ahead and do that. So I'm going to play a simple C scale, and then record it and save it.
And that takes you back, when you press that button, it takes you back to the command line.
Yeah, it'll exit whatever command you're currently in. It's a good way to escape anything.
Okay.
So now Albert, who has a separate board and a separate command line interface, is going to type receive into his command line, waiting for a packet to be received. I'll push the boards a little closer together. And we're going to send the song. It's broken up into 64-byte packets and sent via a algorithm that's similar to TCP/IP.
And as you see, if I play it, I should be able to play exactly what Matt played, completely independent from his board.
Because there's 2 sets of speakers here,
yeah,
yes.
2 sets of speakers here. So now that we hear that, now I can actually add on to it. So I'll just play it backwards, C scale, just to show you what's going on. I click the button there.
Now you play it back.
Right, so we can play that back. Doesn't sound great, but
it's all there.
It's all there, yeah.
Yeah.
And then again, I can send it back to Matt, and then he can build onto it again. So Matt will click receive, and I will send it. And
Okay, so there's the send command.
Yeah, you notice now that there's more packets because the file has grown since Albert added his own track to it.
And you ended up writing error correction for the packet system, right?
Right.
Yeah.
The AI communication was a little unreliable at first. Right now it's working well, but at first it wasn't, so we definitely had to make sure that we synchronized the 2 finite state machines and had both the acknowledgments to ensure that the packets were sent reliably.
Okay.
So now I'm going to play Albert's song back. This is on my board. And then the grand finale, I'll add one more piece to it.
So you put a repetitive note on there.
Yep, so now I'm going to play it back.
Cool. So you have a completely general system for sending songs around and annotating them with more music.
Right, so I mean, we're busy college students, so if Albert and I wanted to create a song and I had a great idea for a riff, I could record it, send it to him at his convenience, and he could add his riff when he's free.
Right. Okay. Very nice. Thank you.